Muy buenos días para todos. Bienvenidos a este lanzamiento de Atom Academy. Nos complace tenerlos a todos aquí y a todos los que nos están viendo y escuchando a través de YouTube. Espero que se escuchen bien durante todo este encuentro y durante toda esta reunión. Para iniciar con este encuentro tan especial que tenemos con todos ustedes, pues me gustaría primero hacer una apertura con las palabras de nuestro vicerrector de investigaciones, Faber Danilo Giraldo Velázquez, quien se encuentra conectado con nosotros desde la distancia. Entonces, escuchémoslo en unas pequeñas palabras de nuestro vicerrector.
Muy buenos días para todos. Muchas gracias María Paula por la introducción. Muy buenos días a todos los amigos que nos siguen por las redes sociales, por la transmisión en vivo que tendremos en el canal de YouTube de la Universidad del Quindío y que queda alojada allí. Saludo especialmente al profesor Felipe Aniorte, a la doctora Constanza Borges, a la decana Carolina Valenzuela, que nos acompaña en este momento, la decana de la Facultad de Ingeniería de la Universidad del Quindío, a todos los amigos que se están vinculando a la transmisión. Es un honor para la Universidad del Quindío dar inicio formalmente a la iniciativa Datum Academy, convenio que hemos suscrito el año anterior, cuyo propósito es que la Universidad del Quindío pueda ser punto satélite para Colombia y América Latina en el máster en Datum que se oferta. Data Inteligencia Artificial que se oferta por parte del ESTIA. Datum Academy es un spin-off de la Escuela Superior de Tecnología Industrial, Ingenieros Industriales Avanzados del ESTIA de Francia. Y con esta iniciativa, la Universidad del Quindío quiere empezar a incursionar y promocionar formas alternativas de educación en posgrado. Este es un máster europeo, como más adelante explicará el profesor Phil Ortega y Constanza, que nos acompañan desde Armenia. Pero la idea de este máster es revolucionario, primero porque es un máster que es homologable ante la Unión Europea. Es un máster que también se compone de créditos o gradios tomados a partir de certificaciones de casas informáticas reconocidas como Oracle y Google. Y adicionalmente que es un máster también que promueve que se puedan hacer aplicaciones inmediatas en contextos como de agricultura, de temas tan importantes y pertinentes como sistemas inteligentes, machine learning, procesamiento avanzado de datos, ingeniería de software y demás. Nosotros con esto queremos honrar el compromiso institucional de la conexión territorial que promovemos desde la actual administración en el sentido de tener una oferta que sea pertinente y correspondiente a las necesidades de los territorios y que también permita incorporar las mejores ventajas que tengan aliados estratégicos, como en este caso el ESTIA y Datum. Esta es una iniciativa que ya viene incorporándose en múltiples países, como les comentará el profesor Felipe Niorte. La charla de hoy estará en modo español-inglés. Me corresponde la parte de español para dar la introducción al público colombiano latino que se conecta. No obstante, tenemos también un destacado profesor desde la Universidad de Pau, en Países de Ador, en Francia, el profesor Conduc Pam, que nos estará indicando las ventajas de aplicar sistemas inteligentes en el sector agro. Y la idea con esto, a través de la Facultad de Ingeniería, próximamente estaremos indicando entonces cómo empezamos a recopilar la información de interesados, dado que también es menester de la Facultad de Ingeniería, además de hacer los registros respectivos, empezar esa interacción con Francia para poner a andar formalmente la iniciativa. Esperamos que la iniciativa pueda ser de bastante acogida, son temas de mucha pertinencia, muchísimo impacto. Nos ofrece una oportunidad también de combinar los saberes tradicionales que manejamos desde la academia, los generados en investigación y sobre todo los saberes también que están generando puntualmente desde la práctica de la industria informática. De ahí la ventaja que tengamos allí gradeos y créditos específicamente asociados a certificaciones de estas casas matrices que son tan apetecidas en el mercado. Y esperamos próximamente entonces consolidar todo este relacionamiento con Francia, que ya entre otras ha permitido, además de las dobles titulaciones que tenemos a nivel de formación postgradual, empezar a promocionar este tipo de máster, unas metodologías virtuales bastante innovadoras y que tienen acompañamiento permanente desde Francia. No quiero extenderme en mi discurso, les agradezco enormemente a todos. Los canales de atención tanto de la Facultad de Ingeniería como la Vicerrectoría quedan a disposición para dar mayor información sobre la iniciativa. Ahora quiero entregar la palabra nuevamente a los amigos en Armenia, a María Paula, al profesor Filip y a Constanza, para que iniciemos formalmente con la explicación de la iniciativa. Un abrazo para todos, muchísimas gracias.
Bueno, gracias por las palabras del vicerrector. Quiero presentar al director de Indicatic ahí, palabras de Philip, pero antes de eso me gustaría hablar un poco de él. Philip Añorte es director de Indicatic en Panamá. Desde junio de 2022 fue profesor titular en la UPPA de Francia desde 2006. Obtuvo su HDR en 2004 con un trabajo sobre sistemas distribuidos mediante ingeniería dirigida por modelos MDE, enfoque que sigue aplicando a sistemas complejos, sistemas de sistemas, COS, y sistemas ciberfísicos, inteligentes en áreas como energías renovables, agricultura, ciudades inteligentes y educación 4.0. Con más de 20 años de colaboración con América Latina y América Central, ha liderado proyectos del programa Prefab, IFAC y ECOSNOR. Fue vicepresidente de Colifree y director de su comité científico. Actualmente participa como investigador consultor en el proyecto de brecha digital e inclusión digital en Colombia, en colaboración con UECCI, Ingenieros Sin Fronteras, UPPA, LIUPPA, IND. Ahora sí, escuchamos las palabras de nuestro director.
Buenos días a todos. Mil gracias por la invitación. Es un gusto inmenso estar acá en la Universidad del Quindío, en Armenia, para ese lanzamiento. Recuerdo que hace un poco más de 2 años con Fader, no nada como vicerrector de investigación, pero arrancamos ese proyecto y obvio al momento de lanzar de manera formal esa colaboración con Francia, para mí es un placer inmenso. Quisiera felicitar a Faber y a su equipo para ese logro. Bueno, como lo dijo Faber, me va a tocar explicar un poco esa iniciativa, a la vez de forma global y de manera un poco más precisa, mediante links que pondré. Bueno, primero que todo, y como lo dijo Faber, Datum es una iniciativa francesa. Bueno, es un startup de la escuela que mencionó Faber. Bueno, no importa la figura. La verdad se llama Datum Academy, lo que claramente aclara sobre bueno, el perímetro de la actividad, perdón, de esa empresa. Claramente se trata de formaciones y bueno, hay puntos comunes originales que me parece importante destacar, aun si Faber lo menciona. Primero que todo, son formaciones virtuales, lo que permite cursarla desde cualquier lugar del mundo. Son también dedicadas a un sector, unas disciplinas bien importantes y más importantes cada día. Las palabras claves que ya Faber mencionó: inteligencia artificial, casi solo hablamos de eso, y Big Data. Así que son de gran relevancia, ¿no?, para los profesionales. También decir que esa iniciativa se hace con convenios con grandes empresas como Oracle, bueno, hablando de Big Data, ¿quién más que Oracle? Y también Google. Hay también como que Microsoft como socio, pero básicamente al nivel de los cursos Oracle y Google. Bueno, ¿qué significa exactamente que dentro de, digamos, la malla curricular, luego hablaré del tema, hay cursos propuestos gracias a ese convenio por Oracle y Google? De ello se puede también, más allá que el diploma que voy a comentar, se puede obtener certificaciones en relación con esos módulos de planos. Bueno, esas son las principales características que hacen que esa oferta de formación queda bien interesante. De manera más específica, ¿de qué se trata? Como lo mencionó Fader, hay un máster, maestría, hablando en español, que se puede cursar online, ¿ok? En esos temas. Bueno, saber que al tener un máster de Francia, en ese caso, europeo, ese máster vale en toda la Unión Europea, eso después del famoso proceso de Bolonia, así que, bueno, vale en España, en Alemania, en cualquier país, eso es bastante interesante. ¿Okay? Los otras formaciones son lo que llamamos no solo en Francia, sino en Europa, en el marco de la Unión Europea, grados. ¿Qué son grados? Son diplomas profesionales. Bueno, quizás podría atreverme a hacer el paralelo con diplomados, con un enfoque bien definido, no centrado sobre IA o Big Data o Cloud o sea lo que sea, sino sobre un puesto de trabajo bien definido, lo que permite bueno, una inserción laboral de manera mucho más fácil. Son 4 grados. Bueno, repito, el contexto general es Big Data, inteligencia artificial, pero cada uno tiene sus especificidades. Como lo dijo Faber, también como lo dijo la maestra de ceremonia en su presentación, ahora todos los sectores necesitan sistemas inteligentes y, bueno, de ello hay necesidades en todos los países, en Francia, de tener gente capacitados para ocupar esos puestos. De ello, ¿a quién se dedica? Son, bueno, formaciones bastante cortas y ¿quién puede cursar esa formación? ¿Quién puede necesitar esa formación? Alguien que ya está trabajando en, digamos, Computer Science, pero que siente que necesita capacitación sobre estos temas tan importantes como inteligencia artificial y Big Data. Puede ser estudiantes recién egresados que sienten la necesidad de profundizar cosas que han abordado durante sus estudios. Bueno, eso es el panorama general que había anunciado. Ahora voy a proponer como para hacer las cosas más concretas, o poner, dar una consistencia un poco más, o aterrizar. Sí, bueno, aquí en ese documento general, bueno, hay el máster virtual y los gradeos 1, 2, 3, 4. Se puede dar un vistazo general para como que... Ok, súper. Un poco más hasta el 4. Ya, exacto. Sí, perfecto. Eso para aclarar un poquito, los nombres son en inglés. Olvidé decir, pero bueno, eso me pareció bastante obvio que esas clases, esos cursos están al momento en inglés, pero tenemos el proyecto desde Datum Latam, que es la representación continental de Datum, proponer a quizás a mediano plazo los cursos en español. Eso me permite decir que la estrategia de Datum consiste en crear representaciones continentales, regionales, en todo el mundo, y acá en América Latina es Datum Latam, que bueno, está manejado desde Indicatic, Panamá, al momento, con el apoyo de Constanza Alvarado. ¿Y cuál es la dinámica? Tener varios nodos donde se proponen, perdón, esas carreras. Ahora tenemos un nodo más desarrollado en Armenia, a partir del cual podemos proponer, mediante ese convenio, del cual a mi saber proponer esos cursos. Decir también que en la figura de Atum no deja, como muchos cursos online, al aprendiente solito, sino que hay sesiones de tutoría propuesta desde el nodo, en este caso, la Universidad del Quindío en Armenia. Bueno, unos comentarios sobre lo que pueden ver en la pantalla. Bueno, sin sorpresa, encontramos las palabras clave: Big Data, inteligencia artificial, Oracle, Google, y como lo decía, el focus es sobre, bueno, un puesto de trabajo, así que desarrollador, arquitecto, etcétera, etcétera. Así que quizás ponemos rápidamente el primer link de arriba, por favor, Joana. Vamos a empezar con... Sí, bueno, no importa. Bueno, si huele complicado. Bueno, acá estamos ni más ni menos en el sitio web de Datum Academy y, bueno, pueden ver como una descripción sintética del gradeo, bueno, repito, formación continua corta. Eso puede interesar a muchas personas porque a veces alguien que trabaja, para él no es necesario cursar todo el máster para solo coger unas pocas partes interesantes. Así que les invito a bueno, consultar las páginas de Datum. Eso da un ejemplo, quizás yo siento que me estoy extendiendo, así que quizás no voy a hacer el mismo ejercicio para todas las páginas, pero pueden encontrar en el sitio web hasta el contenido de los cursos. Bien, no voy a extenderme más. Agradezco su atención y obvio estamos a su disposición durante la fase de preguntas o más allá de forma asincrónica. Bueno, podrán contactar a la Universidad del Quindío. Bueno, gracias por su atención, a la orden, y un especial agradecimiento a Constanza que me acompaña en ese trabajo bastante difícil de implementación de Data Latam en América Latina. Muchas gracias.
Philip, podemos repetir de la página de datos, todo lo de los traes, como ya estaban viendo en el momento en que tú estabas listo.
Sí.
Que lo repitas, la parte de los gradeos en la página de datos.
Sí, que retome.
Sí, correcto, que lo vuelvas a tomar.
Ok. Sí, bueno, ok. Así me dicen que quizás es importante reiterar, así que, bueno, acá el primer gradeo que apareció, bueno, arquitecto, Big Data e Inteligencia Artificial, con casos de uso prácticos y que podemos rápidamente, no quiero como que... sí, y ven, bueno, un overview del programa. Pueden descargar el flyer y bueno, eso lo podemos tener para cada gradeo. Repito, gradeo como diplomado, formación continua enfocada sobre casi un puesto de trabajo, ¿ok? Y también, bueno, más exigente, más largo, se puede cursar el máster que se llama EDR, y para virtual, digamos, online, que corresponde a la versión de un máster clásico que existe en presencial. Solo, bueno, destacar palabras clave que me parecen interesantes, como SQL3, como SparkQL, NoSQL, etcétera, que Data Lake, que realmente son temas muy importantes y, bueno, a través de carreras bastante cortas, ustedes pueden tener las competencias para bueno, ocupar puestos de trabajos que necesitan, digamos, tecnologías avanzadas.
Bueno, gracias Philip por esa gran introducción, por esa explicación también acerca de lo que estamos viendo con Datum Academy. Me gustaría continuar con las palabras y bueno, dando introducción al doctor Conduc Van, catedrático en informática en la Universidad de Pau, Francia. Obtuvo su doctorado en 1997 en la Universidad de París. Sus investigaciones se centran en redes de sensores inalámbricos, en donde fue el experto científico en Internet de las Cosas y tecnología LoRa. Desarrolló el marco genérico LoRa utilizándolo en varios proyectos. Además, gestiona recursos y calidad de servicio en la computación en nube. Ha publicado más de 140 artículos y realizado más de 80 presentaciones científicas. Él también coordina el proyecto Prima Intel Iris sobre riesgo inteligente para pequeños agricultores. y Prima Resilink para aumentar la resiliencia de los pequeños agricultores. Ambos proyectos se centran en las plataformas digitales. Siendo así, me gustaría darle paso al doctor para que pueda socializarnos acerca de la agricultura inteligente.
Hello, so if I understood well, it is you give the floor to me, right?
Sí,
Yes, yes, yes.
Yes.
Okay. Thank you very much for the introduction. Do you hear me well? And is my screen? Do you see my screen?
Yes, I can.
Okay. So first of all, I would like to thank Philippe Agnotte and Indicatic ARP to organize with Datum Academy and University of Quindío this event, to give me the opportunity to describe the one particular aspect I want to address in this project. So first of all, as explained, this project is going to focus on smart agriculture, but I want to focus specifically on a very particular aspect. And as you see in my screen, entitled my talk, Digital Innovation in Agriculture, and how we could target smallholder farmer communities. And at the end of the talk, I will present the lesson learned. So without any transition, I would like to say that when we talk about digital innovation in agriculture, we have to know that there are lots of digital innovation in agriculture. This is not a new topic, and I've been recently. I mean, some days ago, I was in Portugal for the Innovation Agricultural Fair, and I've seen an incredible number of nice innovation. This innovation could be on how to design new irrigation system, or how to have drones, or how to have a weather station, how to have sensors, and also how to have robots in farming, and lots of devices that are very interesting from one to each other. So it is definitely no science fiction. It is actually reality. And now we are capable to move from sensors to more global, to what we call a connected agriculture. And as you can see on the diagram here, we can control all the components of the farms from your tablet. So the question is whether this digital innovation are available for all farmers. And actually, one of the problem is most of the innovation that you can see on the market, on the exhibition fairs, are actually possible for large farms, so big companies with a lot of money to spend, but they are usually out of reach for smallholders. So these are the target that we want to address here, and this is what I'm going to present more specifically. So these smallholders usually they are about to manage up to 2 hectares of field, and the fact is they actually represent more than 80% of the world's farms. So more than 80% are small holdings. And they provide about 32% of world food supply on only about 24% of agricultural land. So actually the efficiency is quite good. The problem with with this community, most of them they are quite far from the technology. They are reluctant to use technology, maybe because they don't trust technology, but also because there's a many barriers, such as cost, of course, but also they are not used to use this advanced technology. And also the market is not adapted to this kind of community, because most of the product that we can see on the market or in innovation fair, beyond the cost barrier, they are very integrated, highly specialized, and usually very difficult to customize or upgrade. So you usually have a lot of vendor lock-in phenomenon where you have to stick with one vendor because all the hardware and the software are actually all linked together with very little or almost no interoperability possibilities. So what I'm going to present to you is the Prima Intelleris project, and Intelleris project is funded by the Prima Partnership on Research and Innovation in the Mediterranean areas. And this Prima program mainly focus on how we could use in an optimal way natural resources in agriculture and farming. So we answered 4 years ago to a call that is entitled Low-Cost Lean Solutions for Enhancing Irrigation Efficiency of Small-Scale Farm Management. And this project has been implemented from June 1st, 2021 until end of May 2024. So it's already finished, but we are still in the process of valorizing and disseminating the results. So this is why I'm quite happy to be here to present the main results and the lesson learned from this project. So first of all, when we talk about irrigation with soil moisture sensors, it is not as easy that we think, because once you get the data from, let's say, your sensors, the soil moisture sensors that you plug into the soil, then you actually first have to analyze this data and ultimately be able to decide whether you want to start the irrigation or not. Okay. One of the problems is you have to take a lot of parameters, whether it could be the type of physical sensors that you are considering. There are several types. I'm not going to be into the detail, but depending on the sensing technology, then the output of the sensors has to be interpreted a little bit differently. And then the analysis of the results and how to decide, then you have to take into account many parameters. You have to take, for instance, the soil type. You have to take into, for instance, the plant variety. You have to take into account weather data and so on. So this analysis is not that simple. And then when it comes to decide whether you need to irrigate or not, you again have to try to find some, try to take into account parameters such as the irrigation type, what exists in the farm, and so on. Excuse me for a minute, please. Yes, so sorry about this. And then we have to decide whether we need to sorry, I got interrupted because there was too much noise in the background. We need to yes, okay. We need to take into account the irrigation type, whether it is a drip irrigation, whether it is a sprinkler, whether it is a flooding or gravity, and so on. So all these parameters are not that easy to take into account, and especially when we want you to provide a very accurate system for the smallholders. So we know that actually it is always a trade-off between the cost you want to spend and then the efficiency of the system. And the whole answer we want to provide here is what can research and innovation bring to smart agriculture when we want to target the smallholder community. So for big farms, definitely they can have high-end sensing system, so the cost can be high, and obviously the efficiency is also quite high. I mean, these sensors and all these systems are mature enough to provide the right indication for big farms. Now, when we talk about smallholders, most of them have no technology at all. Okay, so what we expect is by just adding a small cost, okay, deploying some simple autonomous sensing system, we will be able to increase efficiency by, let's say, to reach a given level that allows them to increase their understanding of how the soil is, save water, increase yield, increase income, and so on. So this is what they expect by just having a small cost introducing technology, then maybe the efficiency can be a much higher. So the two objectives, at least the two technological objectives, we have also objectives that I will explain later on, but the three main technological objectives of the project is to be able to build and provide cost-effective sensing system, to be able to integrate advanced technologies using cutting-edge technologies such as IoT technologies, artificial intelligence technologies, decision support system technologies, seamlessly into the framework in order to provide the right notification and the right decision-making process to the smallholders. And on top of that, most importantly, because we are addressing the smallholder communities, we really want to provide a very autonomous system, a system that smallholders themselves could deploy on the field. So we want something like, could be plug and sense. So behind the plug and sense term, the image is something simple. So you can just have to plug in the soil and start getting notification in order to simplify or to have better decision making when you want to irrigate your field. Again, I just want to go back to the fact that I mentioned in the beginning, we're not talking just about the cost barrier, because even if the cost is reasonable, many smallholders are very reluctant to use technologies. There are many reasons. Fundamentally, these smallholders may have difficulties to use technologies, but usually the technology appears very complex. So there's a huge psychological barrier for them to jump into the technological solutions. So when we design a technological solution for these smallholders, we have to be very careful in designing a system that is actually adapted to their needs, but also adapted to the way they perceive technology and the way they want to use technology. Okay, so we really have to adapt the technology to the smallholder, how they want to use it, rather than imposing a way to use technology for these smallholders. So this is a very important point when we discuss with smallholder communities, because it's fundamentally different with big farms, where in big farms they have IT people, they have a lot of people that can take care of the technology. So you can use let's say the traditional approaches to implement technology, which is not the case when we're talking about the smallholder communities. So it is very important in that case to discuss with local actors, to discuss with local stakeholders, and it is very important to have something like a co-development process for these solutions that we want to implement. So in my talk, I'm going to provide quickly some let's say some approaches that we use, and describe a little bit what we call the enablers to be able to achieve this co-development process. So very quickly, what we have in mind from the beginning of the project is to provide a starter kit to be fully autonomous, implement the plug and sense, and provide the intelligent irrigation in the box system. So you see in the diagram here that we believe we manage to build such a system where, as you can see, we have a starter kit in a box with the devices, with the gateways to be able to collect the data, and the whole system is adapted to be deployed by small-scale farmers. And also, we choose to not have internet connectivity required from the gateway to the clouds. Because when we talk with these farmers, we quickly understand that they actually don't have internet connectivity. They may have some internet connectivity on their smartphones, but usually on their farms, there's no, let's say, internet boxes or technologies that we usually have. So most of these farmers only use is internet provided by their smartphones. So what we wanted to have is a whole system that is capable of running without any internet access, without remote servers, without remote clouds, without advanced processing on high-end servers and so on. So we actually do have two versions of the soil census, a very simple one, which focus on volumetric water content. So you can see the sensor probe, and it's not very expensive. So this is why we managed to decrease the price to about 30 euros. And then the other one, which is more complex, uses soil water potential, which is more accurate in order to measure the let's say the strengths of how the root system of the plant could get access to the water stored in the soil. And depending on the type of sensor we use, then it may be necessary to add a soil temperature. For instance, the temperature of the soil is necessary when we talk about soil water potential. Now, let me give you some insight on how we started the soil device. So we started with what we call the full do-it-yourself approach, where all the components, including the PCB, so the printed circuit board and so on, can be directly soldered by our local partners. So we of course, we are not asking the smallholders to assemble themselves, but we are working with local partners. And these local partners, we try to show that it is possible to build a very efficient system from off-the-shelf components, having a full do-it-yourself approach. And these local farmers then will take over and will show this process, and we install the sensors in the smallholders we are working with. But then from the very beginning of the project, when we wanted to have the full do-it-yourself approach, we progressively improved the system in order to have more easy wiring of physical sensors, in order to have better long-range integration of the wireless radio modules, in order to increase also the autonomy of the whole sensor board, to reach several years of autonomy with only 2 alkaline batteries. We also added the solar charging capabilities, that provides infinite autonomy. So I'm going to get back on the feedbacks of all these improvements that we propose, but you can see in the figures here that we actually we went through all these steps of improving the PCB, taking feedbacks from the stakeholders, taking feedbacks from the smallholders themselves, and trying to improve step by step the hardware platform. So at the end, I mean, not at the end, we are continuing, but the latest version of the board we have, it is capable of to be integrated in the case that you see in these slides. And the device is usually configured to have 1 measure per hour. This is the default measure interval. And with this kind of interval, we were able to have more than 2 years of autonomy on alkaline battery. So the version I'm showing you in this diagram here has the solar panel, but I'm going to come back to this later on. But of course, if you have solar panel, then you have to put a rechargeable battery. And in that case, if you have enough solar, but usually it is not really a problem, you can have infinite autonomy. So now in the latest version, anybody can actually order the hardware platform, because we provide all the manufacturing files on our GitHub platform, and it's almost a one-click order. So of course it is not a one-click, but you have to provide the files and then you have to configure something. But we do have tutorials showing how to order them. So it is almost one-click order. So usually spends 10 minutes to order the kit, and then you at least the hardware platform, and then you can receive it. It is completely manufactured by the PCB manufacturers, and then you can receive it directly in your letterbox. The whole system works with what we call an IoT gateway. So maybe some of you are aware of what a gateway is. A gateway is going to collect data from the various devices that you are deploying. Okay, so we can talk about gateways for Internet of Things, but of course we're also talking about gateways or base station for cellular networks. So it has the same meaning. We have like a device that is going to collect data from the devices. So this gateway is really where we put all the intelligence of our system. So this gateway is going to implement what we call the plug and sense, because it's going to collect the data from the sensors, and then it's going to interpret, analyze, and provide the notification and the decision and let's say the decision-making process to the smallholders, typically whether you need to irrigate or not. So it is plug and sense because we really wanted the whole system to be able to work all together with very low configuration process. So here the sensors node are talking directly to the gateway using state-of-the-art long-range radio technologies with very low power consumption. So maybe some of you may know this technology called LoRa. And this allows us to easily deploy the sensors, even if the gateway is from 2 to 5 kilometers far away from the sensors. So this type of technology is also very low power, and this explains why we could achieve more than 2 years of autonomy on the soil device themselves. So this gateway, as I told you, is not connected to the internet by default. But of course, if you have internet, you could exploit the whole power of having an internet connection. You could synchronize the gateway to our cloud and then get the data from the cloud. This could be the, let's say, the more traditional way of using it. But again, smallholders are not going to do that. Okay, they don't want to connect to the cloud because they don't even know what the cloud is, and actually they don't want to use to use a smartphone because it's time consuming. They really want to just look at the information provided by the gateway and take their decision. So this is why it is very important to design several user interfaces. One interface is to quickly provide the notification to the smallholders, and other more elaborated interfaces if you need to have historical data, if you need to have graphics, if you need to have other information for the most advanced smallholders. But believe me, most of the smallholders we are talking with or we are working with, they are very, let's say, they just want to have the simplest notification from the gateway directly. How can we make it smarter? Because the whole idea of a very autonomous system is to embed the intelligence into the gateway. Again, we don't want to rely on heavy cloud processing and decision-making system that is making use of remote servers and so on. So we want to embed everything into the gateway. We want to be able to take into account the irrigation type. We want to be able to take into account the soil type, the geographical areas, whether it is arid, semi-arid areas, for instance. We want to be able to take the crop type, and maybe if we have a local weather station somewhere in the farm, then we also can take into account the local weather data. So again, all this intelligence is implemented at the gateway level. And on the gateway, we have an embedded web application so that the smallholders, if they want to, okay, again, for those who really have more technological knowledge, if they want to, they can use their smartphone to connect to the gateway. So again, it is not it is not a mobile application that requires internet. Okay, we are using the gateway as a Wi-Fi router, and then you just connect the smartphone using the Wi-Fi of the gateway. So actually, you don't need internet at all, and you can interact with the gateway. So as you can see here with us, we have a more elaborated embedded web application with a more elaborated user interface that displays the same kind of information that is displayed on the small screen of the gateway, but presented in a more fancy fashion, in a fancy manner. But most importantly, when we're talking about adding more intelligence, it usually means more parameters. So this is why by using this embedded application, you will be able to unlock the true power of embedded intelligence, where you will be able to define the various parameters for the soil moistures, for the soil, for the soil humidity sensors, and then for the soil, and then for the plant, and then for the weather. And it's also very important to distinguish between very basic configuration for most of the case, and when you want advanced configuration, where actually you can enter parameters such as how old is your sensors, because the output of the sensors should be adapted, whether it's an old sensors or not, and whether you have soil salinity, soil bulk density, and what type of vegetable are you going to plant, when did you plant it, and so on. So we do have basic parameters and more advanced parameters in our application. So we demonstrated that embedded AI forecast, for example, is quite easy to implement on the gateway without any internet servers. So the gateway is going to use a specific version of neural network that we use long short-term memory type of networks. And as you can see on the graph here, we have irrigation cycles, and the actual value of the humidity is in yellow, and the green one is the predicted one. So we were able to demonstrate that this kind of AI-based prediction models can be easily implemented into the local gateways with no problem. So we have been doing a lot of piloting with farmers, with users. We did that in Morocco, in Algeria. We did that in Morocco. And I'm going to then move to the second part of my talk, where I'm going to try to present you very quickly what did we learn from all all these 3 years project, talking with stakeholders, and talking with the farmers, and talking with our local partners. So first of all, regarding the co-development, we went the hard way. So the hard way means that we started with a very simple design, where you have to assemble everything, and we run a lot of capacity building events and tutorial events to show how we could build the entire system. And this is we have to do that because the partners need to put their hands on the hardware in order to be able to say, okay, we co-develop, because we went to a lot of trials and errors, and then we got a lot of feedbacks on how difficult it is to assemble, how difficult it is to wire the sensors. These kind of sensors, they cannot find it. This kind of casings, they cannot find it, and so on. So we went into a lot of trial and errors to be able to end up to a more modular and open hardware platform. So at the end, I already show you this slide, but I just want to show you that we want to through all this version, from version 1 until the latest version, which is version 5. And we actually integrated a lot of feedbacks to get to where we are now. So the latest PCB version is version 5. And one good thing is we actually validated the fact that the integration is quite easy, and the integration is robust, and the device has been tested for several months in outdoor, in harsh conditions, under heavy sun, under heavy rain sometime, even if water is scarce. Sometimes you have rain, you have dust, and so on. So we show that the integration is quite robust. What we also understood is even if the full do-it-yourself approach is very good for teaching, for running capacity building events, usually it's prone to errors because you actually when you solder, you don't know whether the soldering is good or not. When you're wiring, you could have loose wiring and so on. So we try to simplify a lot the assembling of the devices. So what we prefer right now is a one-click order. So we say our partner, okay, go to that website, order the full PCB, because we provide the manufacturing files, and then they can get all the PCB deliver, and this reduces a lot the errors when assembling. But what is good is we still validate it with our partners and with our stakeholders also, that the final assembling and integration into casing can be locally realized, and this with appropriate tutorials actually is not a difficult task. Solar or not solar? Solar may appear as a very good idea, but actually when we, after several months of deployment, solar panel makes the device much more fragile, okay? And the smallholders, they have to install the devices and then use the devices, and then when they want to harvest, they have to collect the devices, store the devices, and so on. So the solar panel is a very fragile part of the devices. Actually, what is important for these smallholders is not to change the battery too often. So if you provide more than 2 or 3 years of autonomy, which is the case, because when we say 2 years of autonomy means 2 years of continuous autonomy. But if you are storing your devices, you are switching off your devices between harvest, then your device with the alkaline battery can last for 3-4 years. So if you provide several years of autonomy, it is better for smallholders than having the solar panel version. It was, let's say, a good added value to be able to adapt the hardware platform to other purposes. Many stakeholders or some farmers, they ask for some customized devices. Some of them would like to have 2 watermark sensors, 2 water tension sensors, to be able to measure water at 2 different depths. This is mainly very useful when you are planting trees, for instance, for fruit. It's less useful when you have vegetable, but for trees, since the root system is quite deep, then it is better to have 2 sensors. And some of them also ask us to have like 6 temperature sensors, as you can see here, to be able to sense the temperature on 6 different depths. So this is good because we demonstrated how flexible is the hardware platform that we designed, and also it's because we went into, let's say, a co-development process to allow this flexibility. Out of the box, an easy deployment has been validated. Also, for some type of sense of water tension sensors, it needs assistance. But overall, if we have the right tutorials to show how to install the sensors, the system has been perceived as quite easy to install. The fully autonomous gateway definitely was an added value because, again, we validated that these smallholders, they don't want to rely on external clouds and so on. They really want to have all the data stored locally and have all the process local to the gateway. Regarding the user interfaces, we show that we need to implement multiple views with incremental complexity. in order to support a wider range of profile from the smallholders, from the very, let's say, basic notification to more advanced notification system, it is mandatory to be able to adapt, okay, to adapt the display to the smallholder profile. So there's only one way to be able to adapt, is to provide multiple views, so that the smallholder can choose which one they want to use. Regarding the parameters, you have to think, you have to know that you need to provide a very basic configuration. If your system needs a lot of parameters that are mandatory, then smallholders are not going to use it. They must be able to use your system with a basic set of parameters. Even if you have to, let's say, make a trade-off between the complexity and the accuracy, even if your system is not optimally accurate, it is much easier for the smallholder to accept your technology if they don't have to go into parameters that they actually don't understand. Okay, so this is why it is very important to provide a basic view with very basic configuration that could be filled by default, and then a more advanced one. Local language is very important, so we went into the translation, and our application can support multi-language. So we have the Arabic version, because we are mainly deploying this in Algeria, Egypt, and Tunisia, and Morocco. So we work with mostly North African countries. But of course, if we are working in Colombia, in Panama, in other where smallholders actually don't understand English, then it's very important to be able to provide the local languages. This is my last slide. I know that the target is to have 1 hour for the whole event, so this is my last slide. Can we save water? What we observe is usually smallholders, they irrigate, they put more water. Okay, usually they just observe the soil, the surface of the soil, and they put more water when the surface of the soil is too dry. The problem is, it is not that a problem, because is it harmful for the plant? Not really. It is just because you put more water than needed. They're not going to put so much water that the plant is going to die, but they're putting more water than needed. So what we observe is, usually without any technology feedback, they irrigate 5 cycles. With feedback from technology, they realize that actually the soil is still humid, so they can skip 1 cycle out of 5. So at the end, we can foresee something like a 20% saving of water. Okay, so this is already very good. So if we are going to optimize more, maybe we can get a little bit more, but already 20% is very good. So we have been doing a lot of events like this one, for instance, and I'm quite happy to have this opportunity here to present the results. But we have been doing raise awareness event, capacity building, technology transfer, knowledge sharing, and so on. And this is my last slide. If you are interested, you can have the QR code of the website, where you can have access to all resources, publications, tutorial, codes, and whatever. And that finished my talk, and thank you very much for your kind attention.
Bueno, continuaremos entonces con algunas preguntas, ¿cierto? Antes de cerrar, si algunas personas que nos estén viendo por YouTube tengan alguna duda, alguna pregunta específica sobre los temas que vimos en el día de hoy, pues es el momento para hacerlo. Tenemos un tiempo corto para esas pequeñas preguntas. Y gracias a los que están ahí conectados, tenemos a William, Margarita García, Jorge Hernán, John Jairo y más personas que nos están viendo. Un cordial saludo para todos ustedes. Gracias por acompañarnos. Y no sé si hay alguna pregunta en específico de algún tema, o eso sería todo por el día de hoy.
María Paula, si me permites un momento, I want to say thanks to Professor Pam for your valuable contribution to this conference about how we can apply technology in a strategic sector such as agriculture. This is a very important contribution for regions such as Quindío, in which we have a lot of challenges around agriculture, coffee, and other commodities. Thank you so much. We hope to strengthen our collaboration with university, with you and other colleagues from LUPA and Professor Philip.
Thank you. Thank you very much.
Bueno, sí tenemos una pregunta, estaba específicamente para Philip. La pregunta dice que cómo es el tema de costos para aplicar a lo que tú estabas comentando.
Sí, bueno. Sí, bueno, el tema de costo, más fuerte. Sí, el tema de costo está como en el convenio. Pero se puede dar bajo el control de un Quindío, se puede dar un orden de idea para los gradeos, son más o menos 800 euros. Serían, bueno, $900, algo así. Y la maestría, orden de idea, como que 4.000 euros.
Vale, ¿alguna otra pregunta? Recuerden que las preguntas se hacen por medio del chat de YouTube, en donde estamos conectados también, por si hay otra pregunta. Bueno, gracias a todos los que nos acompañaron. Gracias por quedarse durante todo este encuentro que tuvimos. Muchas gracias a Philip. Thank you, doctor.
Thank you.
Gracias también a nuestro vicerrector que nos acompañó en esta sesión y espero que todas las dudas hayan quedado claras. Sin embargo, cualquier duda por los medios de vicerrectoría también estamos acá atentos a cualquier inquietud de las personas que nos acompañaron en el día de hoy. También gracias a Constanza por estar aquí desde temprano acompañándonos y que todos tengan un buen día. Have a good day, doctor, and thank you for your intervention in this meeting.
Thank you very much, and have a good day then.
Recordemos entonces que pondremos a disposición todos los canales de comunicación de la Universidad del Quindío para tener atención a las diferentes inquietudes que salgan de cara a el inicio formal de la iniciativa. Y si se requiere alguna información, los correos de la Facultad de Ingeniería, de la Vicerrectoría de Investigaciones o cualquier otro canal de comunicación. Este video quedará también dispuesto en YouTube para que cualquiera también pueda ver asíncronamente la interacción y nos pueda contactar por los medios oficiales de comunicación para mayor información de la iniciativa. Un abrazo para todos, muchísimas gracias y seguimos en contacto.
Hasta luego.
Thank you.
Gracias.
Thank you. Bye bye.
Merci, Jean-Luc.
Merci. Bye bye. Bonne journée.
Bye.